Yanqing Node News, decoding the digital frontier.
Welcome to Watch Yanking Node News. Okay, let's unpack this incredible landscape of small AI models. You might think small means less capable, but what we're about to explore turns that idea completely on its head. We've gathered a stack of cutting-edge research and comparative analyses, really digging in to spotlight the champions in the arena of compact AI, our mission. To equip you someone who, appreciates the technical nuances and wants to quickly grasp what's truly groundbreaking with the knowledge to identify the best small AI model for virtually any function. From, giving your smart toaster a whisper of intelligence to drafting your next masterpiece of code.
Yeah, what's truly fascinating here is how these models are fundamentally redefining what the edge actually means for AI. They're not just, scaled down versions of their larger counterparts. Many leverage truly innovative architectures and compression techniques that are, paradigm shifts in themselves. This push means putting powerful AI directly into our hands, into our devices, our local environments, and that promises unprecedented privacy, efficiency, and, crucially, real-time responsiveness. And don't worry, we're going to keep this as lively as maybe a stand-up set at a tech conference, hopefully with more aha moments and fewer awkward silences.
Okay, sounds good. So let's dive into the absolute tiny end of the spectrum first. Where models are measured in kilobytes and milliseconds, we're talking about the ultra-compact powerhouses, right? The silent architects designed for edge devices, basic command and control. Giving your toaster a brain, as you put it. It's exactly. But there are severely resource-constrained IoT devices and microcontrollers. Edge Impulse's Eon Tiny ML really stands out. We're talking models in the, say, 50K to 1M parameter range, often just tens or hundreds of kilobytes in size, requiring minimal RAM, sometimes as low as 32 KB, and boasting mobile speeds of around 60 to 150 milliseconds.
That's incredibly fast for such a tiny footprint. But, for listeners who are deeply familiar with the trade-offs in these environments, what specific challenges did Edge Impulse overcome, specifically with the Eon compiler, to maintain performance when bypassing a TFLM interpreter? Because other solutions might struggle there, right?
That's a critical question. Yeah. The innovation really lies in how the Eon compiler works. See, most TinyML solutions use a TFLM, a TensorFlow-like microinterpreter. It's basically a small software layer translating the model's instructions for the hardware. The Eon compiler, though, it bypasses this entirely. It takes your trained model and directly transforms it into highly optimized C++ code, specifically for the target microcontroller, whether that's an ARM Cortex-M RISC-V or an ESP32. So no interpreter overhead at all.
Precisely. That direct compilation removes a significant bottleneck, especially when you're dealing with just tens of kilobytes of RAM. Couple that with techniques like int8 quantization, basically representing the model's knowledge using smaller 8-bit numbers instead of larger ones, but cleverly preserving the crucial details in weight pruning. Well, it's a fundamental re-engineering for tiny silicon.
Gotcha.
These models are absolutely ideal for things like abnormal detection, voice print recognition, gesture control, various sensor-based IoT scenarios.
So we've seen how specialized compilation can really squeeze performance onto tiny silicon. But what if the innovation isn't just in how we compile, but in how the AI itself is fundamentally designed for compactness? That's where things get, truly mind-bending, doesn't it? With this quantum-inspired compression from multiverse computing, featuring their chick brain and superfly models.
Oh yeah, what's truly groundbreaking here is their compactive AI compression algorithm. And it's not just a clever name, it's genuinely derived from quantum physics, specifically quantum tensor networks using something called matrix product operators.
Okay.
The fundamental insight is that compactive AI doesn't just prune a model or compress its data in the usual way. It re-encodes the model's knowledge into a far denser, more efficient correlation space. Imagine like a massive, complex sculpture. Instead of just chipping off pieces, compactive AI reimagines it in this multidimensional correlation space, so it can be compactly stored and transported without losing its intricate detail or structural integrity.
Wow.
This allows for compression rates of, get this, 50 to 95%, while maintaining or sometimes even surpassing the original performance.
That really challenges the whole notion of what model size means relative to capability, doesn't it? So if Superfly, with its 94 million parameters, is for those severely constrained IoT devices like Arduinos handling things like Start Quick Wash, and Chickbrain at 3.2 billion parameters is for mid-range devices like MacBooks doing complex reasoning. What were the biggest conceptual hurdles in actually translating these quantum principles into a practical compression method for AI models?
Well, the biggest hurdle was bridging that abstract mathematical framework of quantum tensor networks, which deal with the most efficient ways to represent complex multidimensional data with concrete architecture of neural networks. It's really about representing information more efficiently in this correlation space, not just cutting neurons, but finding a fundamentally more concise way for the model to think. And this allows these models, Chickbrain and Superfly, to run completely offline on terminal devices, offering unprecedented privacy and efficiency. But note, they're API-based, not open source currently.
Right, API-based. Okay, so having seen how microscale AI can give a toaster a brain, let's pivot now to models that are still incredibly compact but possess the linguistic horsepower for complex text generation and reasoning. Think of these as the Swiss Army knives of the small AI world. First up, Llama 3.18b from Meta. It's an 8 billion parameter model, comes in around 3.5 GB quantized, has a massive 128K context window, and typical mobile response times between 300–600 milliseconds.
Yeah, Llama 3.18b is a prime example of balancing power and efficiency in a really versatile LLM. It leverages grouped query attention, or GQA. That's an ingenious architectural tweak allowing the model to process multiple information requests simultaneously, dramatically speeding up its thinking without really sacrificing accuracy.
GQA, right.
And it also supports LoRa for easy fine-tuning. These are efficient adaptation methods letting you customize a pre-trained model for new tasks with very little data and compute cost instead of retraining the whole thing.
Which is huge for practical use.
Absolutely. It's known for strong multilingual and code capabilities, making it excellent for general text generation, Q&A, reasoning, coding, and crucially, privacy-sensitive local operations.
Okay, so Llama 3.18b offers that broad utility. But when we look at Alibaba's Qwen 3 series, they seem to push the envelope on versatility even further. This family spans from a tiny 0.6 billion parameter model that's just 220 millib quantized all the way up to an 8 billion parameter model at 3.5 GB. They boast context windows up to 128K for the larger models and mobile speeds from 120–400 meters for the smaller ones. That's quite a range.
It is. And a critical aspect of Qwen 3's success, particularly in its larger variants, is its use of MOE, or mixture of experts. This isn't just about compression. It's like having a team of specialized mini-experts inside the model. Only the relevant ones wake up for a specific task.
Right, I remember hearing about that.
So, for example, their 30B A3B model might only activate, say, 3 billion parameters during inference, making it incredibly efficient for its apparent size. And beyond efficiency, the implications for global context-aware AI are significant. Qwen 3 has native multimodality and really strong multi-language support across 119 languages and dialects.
119 languages. That's truly impressive, enabling such broad linguistic and multimodal understanding on everyday devices. From your perspective, what are the biggest challenges in developing a truly global, context-aware AI that can actually be accessible on consumer devices like this? And how does Qwen 3 specifically address those?
Well, the biggest challenge is always that balancing act. Broad linguistic and cultural coverage versus model size and inference speed. It's tough. Training a model on 119 languages effectively, without bloating it to an unusable size, that's a monumental task. Qwen 3 addresses this through its MOE architecture, as we mentioned, and also through very careful data curation, essentially creating a highly adaptable and modular system. This means it can efficiently handle multilingual tasks, multimodal interaction, and even local enterprise solutions without needing massive cloud compute for every single request.
Makes sense. And from Microsoft, we have the Phi 3 Mini. This one packs 3.8 billion parameters into about 2.2 GB when quantized. Also boasts a 128K context window and mobile speeds of 150–400 milliseconds. It's genuinely impressive how much multi-step reasoning and mathematical prowess Microsoft has packed into Phi 3 Mini, like a pocket-sized genius.
Absolutely. Phi 3 Mini is highly optimized for mathematical and multi-step reasoning. And this isn't accidental. It's achieved through high-quality data distillation and very specific fine-tuning. They focused on textbook-quality data, really honing its logical capabilities. It also utilizes things like FP8I and T8 quantization and pruning. So yeah, while it's a mini brain, it proves you don't need a supercomputer to solve complex problems, just a really well-trained one for specific domains.
Okay.
It's great for things like educational assistance, complex logic tasks, code generation, and maybe enterprise security, where accuracy in reasoning is absolutely paramount.
That specialization is fascinating, but does that intense focus on math and logic mean it might, fall short in areas where a broader, more general linguistic understanding or perhaps creative flair is needed? Maybe compared to something like Llama 3.1, what's the trade-off there?
That's a perceptive point. Yes, there's a trade-off. Phi 3 Mini's strength is its precision in focused, reasoning-heavy tasks. While it can handle general language, its core distinction is its reliability in areas like math problems or code generation, where accuracy and step-by-step logic are critical. A model like Llama 3.18b might offer a broader, perhaps more flexible conversational experience or more creative text generation. But Phi 3 Mini is optimized for analytical rigor. It's a strategic design choice, really. Deep, reliable expertise in a narrower domain versus broad, general competence.
Got it. Okay, moving beyond just text, what if your small AI could see, hear, and understand across different senses? That's where multimodal models come in, and they're getting impressively compact too. Let's look at Mini GBC 45 Vision from Cost. These models, often based on Vicuna's 7 billion parameters, are around 810 gigi, with a 32K context window.
Right, and what's truly fascinating here, especially with Mini GPT-5, is this concept of generative vocans. It's not just describing an image, it's actually weaving images into the conversation. It's almost like the AI is thinking in pictures and words simultaneously.
Weaving images in, how does that work?
They pioneered this generative vocans mechanism for interleaved vision language generation. They use something called a Q-former to efficiently bridge visual features with the LLM. Think of the Q-former as a highly efficient translator. It extracts the most relevant visual info from an image and presents it in a format the language model can directly understand and incorporate.
Interesting.
They also support PFT LoRa for low-resource fine-tuning, which is great. This really paves the way for truly intuitive human-AI interaction, especially in low-resource settings. Generating images from text, understanding image content, visual reasoning, it's quite powerful.
That ability to interleave vision and language like that feels like a huge leap towards more natural AI interaction. How does the generative vocans approach specifically handle the challenge of maintaining contextual coherence? You know, when the AI is switching between generating text and generating or incorporating visual elements.
Good question. The generative vocan system essentially learns to map visual concepts into discrete language-like tokens, these vocans. This allows the LLM to process visual information almost as if it were just another part of the text stream. It makes the transition pretty seamless. The model learns to understand when to generate a visual element or describe one based on the conversation's flow. Much like a human might instinctively, draw a diagram or show a picture to clarify a point, it's about achieving a unified representation across modalities.
Very clever. Okay, next up we have Google's Gemini 2.5 flashlight. These models range from 3 to 12 billion parameters, typically 260B quantized, and they come with a massive 1 million token context window. Wow. Mobile speeds are around 350-900 milliseconds.
Yeah, Gemini Flashlight is purpose-built for multimodal capabilities, text, image, audio, video, right out of the box. A key innovation here is something they call thought budgeting and automatic fusion. This allows for incredibly efficient multi-chain reasoning. It's like the model intelligently allocates its cognitive resources based on the complexity and modality of the input, making it super efficient for complex tasks involving multiple types of information.
Thought budgeting, I like that.
It makes them ideal for advanced multimodal assistance, complex knowledge retrieval, and also function calling, getting the AI to use other tools.
And not to be outdone, Meta has Llama 4 Scout Maverick, variants from 8 billion up to 70 billion parameters. But the 8B version is a small marvel at roughly 3 GB quantized, and it also features that 128K context window.
That's right. Llama 4 natively supports multimodal input, text, image, video, and it utilizes expert mixing mechanisms, similar to MoE, for efficiency. The key here is its integrated design. It seems built from the ground up to understand and generate across different media types. This positions it strongly for multimodal AI assistance and complex content understanding and generation.
Okay, so beyond the general smarts and the multimodal magic, sometimes you just need a specialist, right? We've got models tailored for everything from writing perfect code to recognizing your mood, all potentially fitting in your pocket. First up, for code generation, Coastal 2508 from Mistral AI.
Indeed, this one's around 2.5 billion parameters, about 1.4 GB quantized 32K context window. Coastal delivers mobile speeds of 180-350 milliseconds, and it's specifically optimized for code generation and auto-completion. It achieves pretty impressive scores, like 69% on Human Evil Pass at 1 and 43% on SW Bench.
That sounds like a lifesaver for developers on the go, like having a super fast coding buddy right on your phone, no internet needed. But, for a developer with high standards, how does Coastal's code quality and maybe error rate compare to larger cloud-based coding assistants? And what specific types of coding tasks is it best suited for on-device?
That's a fair point.
Yeah.
Look, larger cloud models might have access to more recent or niche libraries, sure. But Cosmos excels at common programming languages and frameworks for everyday tasks. Things like generating boilerplate code, suggesting function implementations, maybe refactoring existing code. Its real strength is speed and privacy for that on-device incremental coding help. It aims to reduce friction in the workflow by providing quick, reliable suggestions for a wide range of common tasks. It can significantly boost developer productivity without those round trips to the cloud.
Makes sense. Okay, for retrieval and embeddings understanding, meaning Microsoft and Hugging Face offer MinLM L6v2. This model is incredibly lightweight, just 22 million parameters, about 8 millibit in file size, and it processes 256 characters in roughly 15 milliseconds. Tiny.
It really is tiny. And the broader implication of embedding models like MinLM L6v2 is, well, they are the silent workhorses of modern AI. They're not flashy, but they allow applications to understand context and pull relevant information with incredible speed and efficiency, even on very limited hardware. Achieving a top 5 retrieval accuracy of 78.9% at that size is remarkable. It immediately begs the question, how much fundamental intelligence can we actually pack into just 8 megabytes?
Right.
And what does that mean for creating truly smart, localized search experiences? They are ideal for semantic search, RAG, that's retrieval augmented generation, quick Q&A, generating embeddings where speed and footprint are absolutely critical.
It's astonishing that 8 megabytes can hold that much semantic understanding. So, okay, for a small application developer listening, what's a practical, maybe unexpected use case where MinLM L6v2 could significantly improve user experience without bloating their app?
Oh, good question. Think about a simple note-taking app. Instead of just basic keyword search, MinLM L6v2 could enable semantic search, finding notes related to your query even if you use completely different words.
Oh, okay.
Or imagine a customer support app running locally on a device. You can instantly analyze a user's typed question, embed it, and retrieve the most relevant FAQ answer from a local database, all without an internet connection. That could drastically improve first response times.
Yeah, that's powerful. Okay, quickly through a few more specialists. For automatic speech recognition, ASR, there's NVIDIA's Parakeet TDT 0.6b.
Right, this model has 600 million parameters, about 270 milB. Known for its extremely fast inference, RTFX 3386, they claim. That's lightning fast, delivering results in about 40 meters per 30 seconds of audio. So it's excellent for real-time stuff like voice assistance and transcription, where ultra-low latency is paramount.
And for text-to-speech, making the AI talk, we have Kokoro V1.0 from Hexgrad.
Kokoro is an ultra-lightweight gem. 82 million parameters, only about 50 milligig. Offers mobile speeds around 200 meters and supports rich pronunciation packages in English, Japanese, Korean, French, and Chinese. Deployable on low-end devices, great for mobile apps needing localized, natural-sounding speech.
Okay. Optical character recognition, OCR. Consider Baidu's Paddle OCR Lite 3.7.
Hyper lightweight, just 3.5 million parameters, 3.5 MB file size. Processes an image in about 50 meters with 94-97% accuracy. It's specifically optimized for Chinese, English, and Japanese, and supports CRNN for multi-table recognition, understanding complex table structures in documents.
Useful.
Perfect for industrial cameras, mobile scanning, batch processing documents like receipts, especially on extremely constrained devices.
And finally, for dialogue emotion classification, there's Microsoft's MinLM E6 Emotion. You mentioned this earlier, the idea that a model weighing less than a single high-res photo can tell if your customer is happy or frustrated in milliseconds. That's some serious efficiency.
That's precisely the point. This model is incredibly small, 22 million parameters, roughly 9 MB, and extremely fast. Classifying emotions at about 22 meters per turn, it's optimized for classifying, say, 3 to 7 basic emotions. Prioritized for chatbots, customer service, call centers. Anywhere quick on-device sentiment analysis is needed to tailor responses in real time.
Phew. Okay, last category. Let's talk about the master conductors. The frameworks and small models that allow AI to use other tools, automate complex workflows, and act as intelligent agents. We're diving into agent toolchains. One prominent example is Crew AI from the open source community.
Yeah, Crew AI is fascinating because it's LLM decoupled. It focuses on role-based and memory orchestration. It really emphasizes a professional division of labor and multi-agent team parallelism. Each AI agent has a defined role, memory, goal. Integrates seamlessly with things like VS Code and other IDEs. This makes it incredibly powerful for building complex, collaborative AI agent systems for diverse tasks. You can have specialized small models working together for a larger objective.
Like an AI project team.
Exactly. And from Microsoft, we have the Mu agent. What's genuinely exciting about the Mu agent working within Windows is its sort of discrete yet powerful presence. At just 330 million parameters, around 180 members, with mobile speeds of 300 meters, it's an ultra-lightweight agent specifically designed for native on-device deployment. Extremely low energy consumption.
Right, for Copilot plus PCs.
Precisely. It demonstrates that powerful responsive AI doesn't need to live in the cloud to be smart. It can be a silent, low-power partner right on your local device. And the broader implication, connecting it to the bigger picture, is that this changes how we think about privacy and instantaneous AI assistance, especially for those Copilot plus PC scenarios where local, secure processing is a key selling feature.
What a journey, seriously. From quantum-inspired compression-squeezing AI onto potentially a toaster chip, to specialized coding companions and multimodal models that can think in pictures and words. This deep dive has really shown just how truly powerful small can be in the world of AI.
Indeed. The common thread woven through all these different innovations is a relentless pursuit of efficiency. Whether that's through sparse architectures like MoE, advanced quantization, clever data distillation, or entirely new compression paradigms like compactive AI. This commitment to small but mighty fundamentally democratizes access to advanced AI capabilities. It makes them faster, more private, and importantly, more environmentally friendly too. It truly is a paradigm shift. And it proves that the best model is always the one that's perfectly tailored to its specific application and its resource constraints.
Absolutely. So as these tiny titans continue to evolve, here's something for you to consider. What previously impossible AI application, maybe constrained by size or power, could you now build with these pocket-sized marvels? The future of ubiquitous, intelligent computing might just be found in the smallest packages.
It's really about empowering the next wave of innovation, isn't it? Putting advanced AI capabilities into the hands of developers and everyday users alike on the devices we already own.
Well said. Thank you for joining us on this deep dive into the best small AI models for different functions. Until next time, keep exploring, keep innovating, and keep being brilliantly informed.